Don, it's a reflection of the importance of consciousness, but maybe the desperation of certain scientists, that several are going to the level of quantum physics to try to explain consciousness. Why do they do that?
Well, on the one hand, it is our deepest science, and it's our most worked out, and so we have good foundations there. But we've not been able to figure out how to connect consciousness to neural activity at the higher levels, at synaptic levels, ions crossing membranes. We haven't been able to do it
Neural
there.
circuitry.
Neural circuitry, that's all right. Systems of neurons firing. So we haven't been able to do it successfully there. And so then the idea is, well, maybe something at the quantum level, which is very, very basic physics. There are aspects of quantum mechanics where the observer seems to be playing a role. Wigner and von Neumann brought consciousness in themselves when they were talking about quantum theory, and they were smart guys.
Yeah.
So several researchers, and that I include Minas Kafatos and Henry Stapp and Roger Penrose and Stuart Hameroff. These researchers are starting to look at quantum mechanical levels of brain activity. And for example, Hameroff and Penrose are looking at quantum coherence in microtubules and collapse of the quantum wave function according to some advanced physical principles that Roger Penrose has worked out. And these are very interesting directions to go. But no one has yet expelled the magic. And they have quantum properties, collapse of quantum coherence, but I think people who aren't there in their camps still have the question, what in the collapse of quantum coherence in microtubules gives rise to consciousness? Maybe quantum states are global and there's something about consciousness that's global, but can we make a more definite connection between them? And in particular, why should this collapse in this microtubule be the experience of the smell of a rose? Why couldn't it be the taste of garlic? There's no attempt in any of these theories to have the kind of precision that we really want from a scientific theory of consciousness. We want a mathematically precise theory that says these, if we're going to do it from quantum mechanics or physical properties of the brain, that says these quantum properties or these physical properties of the brain must produce these kinds of qualia, these kinds of conscious experiences. This coherence has to be, or this collapse has to be the taste of a strawberry. It could not be the sound of a trumpet for these mathematically precise reasons.
It's the same issue when you have a neuron and a synapse of a neuron at a much higher order of magnitude and size. It's the same issue.
It's absolutely. We've gone down even to what you might call the Planck scale, which is like 10 to the minus 35 meters.
Yeah.
Really, really small, where physicists think it doesn't get any smaller. Space-time itself breaks up into little, it's no longer smooth. It breaks up. But it's the same problem at that scale as at the scale of neurons, whole neurons, or systems of neurons, and that is how to bridge the gap from the physical properties of the system to the quality in a principled way. I mean, let's not fool ourselves. We're scientists. We want a precise theory that makes precise predictions. It says this physical property must be this quality, and we'll tell you why it has to be the taste of chocolate. It has to be the taste of chocolate for these reasons. And if you make these small changes in the physics, then it will be, the taste of a strawberry, and it's for these precise reasons. People in the field who hear me saying this would go, we're nowhere near that. I mean, there's nothing like that in our field. And because we have no clue yet how to go remotely from physical stuff, even at the quantum level, to the true properties of consciousness, qualia. So it's again, we're in a position where there really are no genuine scientific theories, which is not to say we shouldn't try. I mean, it's happy hunting in the quantum world. Let's look and see if we can find some ideas. But let's not fool ourselves. We don't yet have a theory.
Do you think it's even conceivably possible that activity on the quantum level, which is so many orders of magnitude below what's happening in the synapse between neurons, where most people think the learning and memory and cognition takes place, do you think that's even in principle logical?
That we could bridge a gap all the way from the two?
Yeah.
Well, I think most scientists think that there is going to be a consistent story that ties physics at all levels together from the Planck level all the way up
Well,
to...
but the same is true in this table.
Right.
Because the same physics at the Planck level is in the quantum collapse. That's what causes every matter in the world.
Right.
The question is, there's something unique in the consciousness part, where it happens in the brain,
Right.
or microtubules within neurons, that uniquely causes consciousness. That's the challenge.
That's fair point. And there the challenge is we don't even know at what level to try to answer this question. I mean, Planck scale is 10 to the minus 35 meters. That's really, really small. Neurons are enormous and everything in between is fair game. So that shows how, we're shooting in the dark in some sense. Is it spiking rates of neurons? Is that what causes consciousness? Or the systems of spiking, complex integrated systems of spiking neurons? Is that the level? Or we're guessing all the way down to 10 to the minus 35 meters and activity down there. What that really says is we're throwing a dart at the board right now. We don't know where to, and we have to. I mean, I'm not criticizing. I mean, we have to, we don't have an answer, so everybody's got to start searching wherever we can. But it shows what we can't do is claim that we've got a theory.
And you've done the reverse, though.
Right.
You've looked at not just the quantum physics of consciousness, but you're saying that's not working, but can I go the other way?
That's right. So you can try to get consciousness out of quantum physics. And I'm taking the opposite approach. I'm saying I could be wrong, but let's try it. Let's get a mathematically precise theory of consciousness. And then let's see, without any hand waves or miracles, can we get quantum mechanics coming out of it? And I think we can. So I've been working with a mathematical physicist and mathematician, and we have, we can get the quantum wave function of a free particle from a dynamics of what we call conscious agents. So in principle, it is possible.
Well, I may be very old-fashioned, but as astonished as I was that some people are using quantum physics to explain consciousness, I am even more astonished that you are trying to derive quantum physics from a mathematically precise a structure of consciousness. I find that fabulous in all the negative connotations of the word.
I certainly understand. And so the burden is on me to have a mathematically precise theory. So I do have a mathematically precise theory of what I call conscious agents, involving things called Markovian kernels and so forth. But the real proof of the pudding is, can I actually get, for example, spinors in quantum mechanics? Can I get Penrose's spin nets coming out? Can I make new physical predictions that current physical theory cannot make? Right now, the connection between consciousness and physics that I'm looking at, it appears that the long-term properties of my dynamics, what was called the asymptotics, is what physics is dealing with. In which case, physics, as we know it, would be the special case of the conscious dynamics as what you might call the time parameter goes to infinity. In the same way that classical physics comes out as the limit of relativity as the speed of light goes to infinity, or as, in the case of quantum mechanics, as Planck's constant goes to zero, you get classical mechanics coming out. So my idea would be, in a similar fashion, to get quantum theory and relativity coming out as a special case of the conscious dynamics, as a limiting case as my time parameter, my quote unquote, it's not really time, but it's the dynamical parameter of my system, goes to infinity. The asymptotics of my dynamics ends up being the physics. That's the goal. So, but the nice thing is, it's not a hand wave. It's a precise attempt.